Hello everyone, welcome to chapter 15. In this chapter, we're going to talk about insoluble ionic compound and their solubility product. We see here crystals. This crystal is called fluoride, CaF2. This one is deposited through precipitation reaction, and the other minerals like kind of contaminants are present, small amount, minute amount. This one is present here, and that is contributing to the beautiful color of this one. So the topic of this chapter is now precipitation reaction. We're going to see precipitation and dissolution. We're going to review in this part the solubility rules of ionic compounds. We're going to study precipitation reaction and their solubility product. And we are going to see also selective precipitation. We have different kinds of cations, metal cations present in a solution. Then when you treat this one with pH or different pH or other anions, then we can selectively precipitate some of the cations. Here in this picture, we have lead to iodide, the precipitate. We see the yellow like hazy like solids formed as a result of mixing lead to nitrate and potassium iodide solution. In this Erlenmeyer flask, we have lead to nitrate solution, and when we add potassium iodide, as soon as they are mixed together, we see yellow precipitate, which is lead iodide. So in this part, we're going to see how to determine the solubility product. Like, what is this insoluble ionic compound? We are going to revisit, and then we're going to calculate solubility product and its solubility of this insoluble ionic compound. Insoluble substance, we learned this one previously in Chem 201. This one is in an ionic compound that does not dissolve in water. Specified solvent, usually water in aqueous solution. This one is, there is not absolutely, this one is not dissolved significantly. So this one is dissolved little bit, but that amount is not significant. Then what is the significant amount of dissolution? That is 0.1 molarity, which is 0.1 moles of ionic compound per liter. So if the solubility is not less than 0.1 moles per liter, we consider that ionic compound as insoluble in water. For example, there are many insoluble ionic compounds. Among them, lead to chloride, calcium hydroxide, strontium hydroxide, and barium hydroxide. Their solubility is now 0.1 molarity, which is at the boundary of soluble and insoluble. We call this one slightly soluble. Now let's make a review of solubility table that we studied in the previous class, Chem 201, General Chemistry 1. In this slide shows soluble compounds. The soluble compounds contain these anions, then there is usually soluble. There are certain exceptions on here. When the compound containing nitrate, acetate, chlorate, perchlorate, then that ionic compound is all soluble without any exception. Now, when the compound contains halide, chloride, bromide, or iodide that is usually soluble, there are certain exceptions. When the halide is now combined with silver ion, mercury 1 ion, or lead 2 ion, then it becomes insoluble. Sulfate ion is usually soluble, but combination with alkaline earth metals, for example, calcium 2+, strontium barium ions, or silver ion, mercury 1 ion, lead 2+ ion, then it becomes insoluble. This one is now common factor with this insoluble exception with halides. Now what this slide shows is insoluble compounds. Compounds that contain these anions are usually insoluble. Sulfide ion is usually insoluble. Carbonate, phosphate, or hydroxide ions, when an ionic compound is containing these anions, that ionic compound is usually insoluble. There are exceptions. The ammonium ion and alkali metal cations, lithium, sodium, potassium cations. When this one is combining, it is always soluble. As you see here, these are all exceptions here. For sulfide, there are also other exceptions. Alkaline earth metal cations also exception. Calcium sulfide, strontium, and barium sulfide, they are also soluble and exception to this insoluble general rule. So insoluble ionic compound is now silver chloride. This one is insoluble. This silver iodide, silver bromide, silver chloride, they are all insoluble ionic compound, but they have a minute amount of silver ion and chloride ion dissolved into water. Also, silver ion iodide ion is dissolved into water. Lead 2 sulfide is now insoluble. Insoluble meaning it's absolutely zero amount of these ions dissolved. No, it's not. There are small amount, a very minute amount of this lead 2 plus ion sulfide are dissolved, this one, but this amount, solubility is not significant, specifically less than 0.1 moles per liter. Aluminum hydroxide, iron 3 hydroxide is also insoluble, and then small amount, minute amount is compound is not dissolved into water and producing aluminum 3 plus ion and lead 3 plus ion and hydroxide ion. So these cations, these insoluble ionic compounds mostly present as solid precipitate, and they are sparingly soluble. Minute amount of these ions are soluble and staying as these ions. So we want to study this one quantitatively by defining solubility product, and using this solubility product constant, we have to calculate solubility.